Here are some other practice problems. In a sample of 500 students, the average GPA was 2.53 with a standard deviation of 0.24. How many GPA points are between -1 standard deviation from the mean and +2 standard deviation units from the mean? Also, calculate the percentile rank for a GPA of 3.0. And what GPA is 2 standard deviation units below the mean? Go ahead and work through these sample problems. Then go ahead and unpause this video when you've got your answers. Okay, so let's see if you were able to figure this out. So for the first one, how many GPA points are between -1 standard deviation from the mean and +2 standard deviations from the mean? Well, we know that we have the mean of 2.53. We have a standard deviation of 0.24, so one standard deviation is really equal to 0.24 GPA points. So -1 standard deviation is going to give us a corresponding GPA of 2.29 because our mean is 2.53 minus 1 standard deviation unit, which is equal to 0.24 GPA points, gives us 2.29. The GPA that corresponds to 2 standard deviation units above the mean, well, we have the mean plus 2 standard deviation units, which is equal to 0.24 GPA points, gives us a GPA of 3.01. So if I wanted to know the GPA points between -1 standard deviation and +2 standard deviation, we then take a difference of those to give us 0.72 GPA points between -1 and -2 standard deviations from the mean. Second problem, calculate the percentile rank for a GPA of 3.0. So since I was asking for the percentile rank, that should tell you, hey, I need to do the z-score to be able to get from a z-score to a percentile. And so I've given you the GPA of 3.0, so this 3.0 is going to be your individual score. I've given you the mean, and I've given you the standard deviation. So once we plug all that in to the z-score formula, 3.0 minus 2.53, all of that divided by 0.24 gives us a z-score of 1.96. That z-score then corresponds to a proportion of 0.9750. Since I asked for the percentile rank, we multiply that by 100 to give you 97.50. So somebody who has a GPA of 3.0 among the sample of 500 students is doing better than 97.5% of their classmates. So somebody who has a GPA of 3.0 is doing really, really, really well among their classmates that have an average GPA of 2.53. Last question. What GPA is 2 standard deviation units below the mean? Well, this is kind of just like the first problem. We have the mean, 2.53, and we want to know what the GPA is 2 standard deviation units below it. So the mean minus 2 standard deviation, 0.24, is equal to a GPA of 2.05. Here are even more practice problems. So here is an SPSS descriptive statistics table. You see we have 4 different variables. We have a sample size, our mean, and our standard deviation. So using this table, answer the following 2 questions. What proportion of people walk 15 or more minutes for leisure? And how many cigarettes are smoked in a day that correspond to a z-score of 1.90? Go ahead and see if you can answer these problems. Go ahead and come back to the video once you've got your answers. All right, so let's see how you did. So the first question, what proportion of people walk 15 minutes or more for leisure? So So we know we have proportions, so that means we have to use our z-score table. And we see we want to know the people that walk more than 15 minutes. So this is a greater than question, so that means we know we have to do the opposite. So we have our individual score, which is 15, and we look at our table for leisure, and we just plug in our numbers into our z-score formula. So z is equal to 15 minus 33.88 divided by 36.07. And that corresponds to a z-score of negative 0.52. So we're seeing that somebody who walks 15 minutes or less is walking less than average. Not only can we just compare that 15 minutes to the mean, but we see that our z-score is a negative number, so that's less than the average. But since we wanted to know the proportion of people that walk, we have to convert the z-score to proportion. So once we have that z-score, we then look at our z-score table to find the corresponding proportion. And we have 0.3015. So right now, 0.3015, or we converted this to a percentage, 30.15% of people walk 15 minutes or less for leisure. I wanted to know the proportion of people that walked 15 minutes or more for leisure. So we then have to take this proportion and subtract it from 1 to give us 0.6985 of people walk 15 minutes or more for leisure. If we simply converted this to a percentage, we would say that 69.85% of people walk 15 minutes or more for leisure in this sample of 1,352 people. What about the second question? How many cigarettes are smoked in a day that correspond to a z-score of 1.90? This is a little tricky. So we are given the z-score already. I want to know how many cigarettes are smoked. So if we look at our z-score formula, what term are we looking for? We're looking for the individual score. So we need to convert and manipulate our z-score formula so that we get our individual score is equal to our z-score times standard deviation plus the mean. And then we just go ahead and plug and chug. And number of cigarettes smoked equal to 1.90 times 2.94, which is our standard deviation, plus our average number of cigarettes smoked, which is 3.32. So once we do all that math, we see that 8.91 cigarettes are smoked in a day for somebody that has a z-score of 1.90. So this is just one way of looking and saying, if we have our z-score already, how do we find out an individual score? So putting it all together, here is a nice distribution curve that really just shows all of these things in terms of the percentages underneath the curve, some deviation units, our percentages, percentiles, and our z-scores, and how they all relate to each other. Notice that the standard deviation and z-score numbers are exactly the same, and as well as our cumulative percentages and our percentiles, that they all correspond to the same. So here are some helpful videos to watch. Again, these are some of the ones that I had mentioned throughout the lecture already. So these are just another way for you to watch these. You can watch them on Titanium as well. And they're all provided to you by Khan Academy. So just to summarize, normal distribution contains all possible answers for a variable, and that variable needs to be ungrouped interval ratio. The normal distribution is also symmetric, has one mode, which is also equal to the median, and is also equal to the mean, and it has a predictable shape, which is symmetrical and bell shape. And again, this is evidenced by the z-score table, where we can predict and know how many percentages fall within any given part of the curve. And so using the z-score table, we use a calculation to figure out the percentages and the percentiles that correspond to a given score, as well as the percent of scores that are greater than or equal to, or less than or equal to, a given score. And we have the empirical rule. Plus or minus 1 standard deviation contains 68% of all scores. Plus or minus 2 standard deviations from the mean contains 95% of all scores. And plus or minus 3 standard deviation units from the mean contains 99.7% of all scores. So just a few reminders. Proportions and probabilities range from 0 to 1. And this is what we get from the middle of the z-score table. So we want to keep all those numbers by rounding 4 decimal places to the right. Percentages and percentiles range from 0 to 100. So these are rounded to 2 decimal places to the right. And we simply would just convert our proportion or probability, multiplying it by 100. Any z-scores that you get, round those to 2 decimal places to the right. Again, we need these 2 decimal places so that we can look up the z-score on the z-score table to find the corresponding proportion or probability. And so mini quiz 7 will help reinforce the material covered in this chapter. And homework 3, it's a big homework. It covers stuff from last week, hypothesis testing, covers stuff from this week, and also covers stuff from next week in chapter 9. And then you'll have a major component in making graphs and tables using SPSS. So I encourage you guys to get started sooner than later. You guys have a couple weeks from this week to go ahead and submit homework 3.